Okay, so let's suppose, and please give me a point. Any point you want. Perfect. 3. Very good. Awesome. So there is a line passing through this point and perpendicular to, please give me any equation you want. It has to be a line. What do you think? Yes, perfect. Perfect. If you want to stop, you can stop, or you can say +5, +3, whatever, or you can stop. Perfect. So now, this is the scenario. I'm not graphing exactly anything, okay, accurately. So this is the equation of a line that we don't have. About this line, we know two things. One, that somewhere along the line, we have this point, which is -2, 3. That's one piece of information. The second piece of information is that this line, oops, I didn't mean to, so this is the point. So the unknown line is perpendicular to this line, which is y equals 1/4 x. Here's what I ask myself now. Is this the y-intercept? Because if you say yes, then I will write y equals mx plus b. But is it? No. So I will not write this, and I only have another option, which is y minus y1 equals the slope times x minus x1, in which I am given the point. This is x1, and this is y1, but I am missing a very important piece of the information, of the important piece for determining the equation. So what am I missing is the slope. So how do I determine the slope of the blue line, knowing that the slope of the orange line is 1/4? So m2 equals 1/4. For perpendicular lines, we have two options. The one option is m1 equals -1 over m2. It's a mouthful. I prefer product equals -1 because you cross multiply. Regardless of which one you prefer, tell me how much is m1. This is here the slope of the first line, or the unknown line. What will I say? How much? But is -1/4 times 1/4 -1? If the answer is yes, then it's -1/4. So this is 1/4. What do I multiply 1/4 by to get -1? And that cannot be -1/4, because -1/4 times +1/4 is not -1. Indeed. Only -4/1 times 1/4 will be -1. Everyone agrees? Any questions? Perfect, thank you. So this is -4. So now I have the equation. Y minus 3 equals -4. X minus -2 is x plus 2. Is this okay? Yes? Any questions? Stop me if you have questions, please. So I distribute -4x minus 8, but I have to add 3 by moving -3 to the other side, and then I'm done, which was -4x minus, minus 5. Now what does this represent? It represents the equation of the blue line that is guaranteed to pass through -2, 3, and also guaranteed that is perpendicular to y equals 1/4 x. Now, is this better? Please.
I understand everything you did except for how you multiplied m1.
That's the rule. Two lines are perpendicular if the product of the slopes is -1. Two lines are parallel if they have the same slope. If two lines are perpendicular, m1 times m2 must equal -1. Perfect. Is that clear why it's -4? Because only -4/1 times 1/4 will give us exactly negative. This cannot be +1 or anything else. It must be -1. Very good question. Thank you. Anything else that we worked on? Anything else that you would like to see? Don't be shy, please. Anything that you worked on in my math lab? Anything you'd like to see again? Yes, please. Awesome. So let's create a function. Any function you want. Give me any function you want. It can be quadratic. It can be rational. Anything you want. Any function. Linear. Square root. Whatever. Okay. So the square root of whatever you want. X plus 2. Good. So now we have to find an x1 and we have to find an x2 that we would like to, it will be given to us. In this case, we're just making up the problem, so that's why we don't have them. So let's think, what should I put here so I can really get a nice answer? 2 is 1, very good. What else can I put in here so I can take the square root nicely? Very good. So here it is. So we are given the function that is the square root of x plus 2. We are asked to find the average rate of change between 2 and 7. So what is the definition? And you can say is the slope. It will be y2 minus y1 over x2 minus x1. However, we prefer for the average rate of change to write instead of y2 what? Excellent. F of x2. And instead of y1, very good. And x2 minus x1. The denominator is very clear. It's 7 minus 2. Agreed? It's y2. I'm sorry. If x, it's x2 minus x1. Well, what about the numerator? Right, so how much is this? This is when I plug in 7. 3. Minus. This is when I plug in 2. So the square root of 4 is 2. The numerator is 1, the denominator is 5, and that is the rate of change. Forgive me. The average rate of change of the given function between the given points, please. Yes. The x1 and x2 are given to us, but since we created everything, we also created x1 and x2. Thank you. So that, yes, those will be given to us. Anything else that you would like to, very good question, thank you. Anything else that you would like to go back to? Any type of problem? Okay, so one more time. Today we are going to try to finish 2.5, which is the last section before the test. Tuesday, the 9th, we will have this test. And on Thursday this week, like today, if we have time, we will review. I did give you a copy of a summary, if you want, of different problems. And we're going to start with that. However, I can start with any problems you may say, like your colleague said, show me another, show me another. So whatever you want. Okay, so do you have anything else before we look at the last section? Anything else for me? Okay, so this is called transformations. And you can say, what is that? In a minute, we'll explain. However, I'm going to say this, that this means nothing unless we know. This means nothing if we don't know what it's called base, or some people call it basic functions. Mainly they're graphs. So there is no point in talking about transformations if I do not have a good foundation of the basic the simplest possible, roughly 7 functions. So we're going to look at polynomial functions, 4 of those. One is linear, the other one is quadratic, cubic, and 4th degree. We're going to look at the absolute value function. We are going to look at the square root and the cube root. That's all we need. So 1, 2, 3, 4, 5, 6, 7 functions that we should, they're graphs, we should commit the graphs to memory. Because otherwise, this means nothing. So I can understand and talk about transformations if I know the graphs of these functions. If I don't remember the graphs of these functions, that is useless. Okay, so let's look at the basic graphs. Let's start with number 1, linear. I'm asking you, please give me the simplest possible linear function on the planet. That's it. That is the simplest possible linear equation. We cannot find a simpler one. So, we are going to graph it. We should know this by now, that the graph of f of x equals y is the line, and this is very important for the next steps in chapter 2. This is the line that bisects the first quadrant and the third quadrant. Now, I would like you to look at the graph and say the function is symmetric, and I will ask you what type. What type of symmetry is this? So if you remember, we have 2 types, and we will practice that, please. Odd. So if the function is symmetric with respect to the origin, we call it odd. If it's symmetric with respect to the y-axis, we call it perfect. So this is indeed odd. Agreed? Perfect. Number 2, quadratic. Please give me the simplest possible quadratic function that anyone can come up with. Very good. So this is f of x equals x squared. We will go back to details of this function in chapter 3. But for now, we did use it before, and this is the graph. This is the graph of x squared. Odd, even, or none of the above. Do you all agree with even? Perfect, awesome. Please ask questions, any questions you want. Okay, the next one is cubic. Can anyone give us a polynomial function of degree 3? The simplest possible that anyone can come up with. So this is f of x equals x cubed. We graph this. Oops, I didn't mean to put the arrow here. I will erase it. So, do you remember when we graphed this function? When we talked about... No, we did not graph it then. We graphed it when we were talking about... Remember the graph? When we talked about symmetry. This was the graph that we illustrated, that f of negative x must equal f of x. Good. So now the cubic function. I'm going to graph it. And please tell me if you remember it and when we looked at it. Now be very careful at the graph because I need this for chapter 3 and I like to establish it now. Here's the graph. Notice that it does not cross the x-axis like this. It crosses the x-axis in one point, but it reaches that point very slowly, not fast. This is fast. It reaches it very slowly. Okay, when did we see this function? When we talked about, yes, when we talk about odd functions. So is it odd, even, or none of the above? Very good. Okay, now please pay attention to the next function that is a 4th degree function. So please give me I meant to write G here, degree. So can anyone give us the simplest possible 4th degree function? So it's f of x equals f of x equals x to the 4th. There is similarity between x squared and x to the 4th. However, say it again. No, not at all. No, just a tiny bit. But let's take a look. And let me ask you if you see what I'm trying to show. And what is the difference between these two? It's the same with the difference between these two. This one crosses, and this one crosses, but it takes its time. And I'll explain in chapter 3 why. Now see the difference between these two. This one turns quickly, but this one takes its time. I'll explain why in chapter 4. So please understand the difference between these two. Something very important. Number 5. Absolute value. F of x, the simplest possible absolute value is, very good. We did graph this function on the first day. And if you remember, it's also called a blah, blah, blah function. V function indeed. It bisects the first quadrant and the second quadrant. So this is the graph of the absolute value of x. Odd, even, or none of the above. Very good. Which means symmetric with respect to the y-axis. Number 6. We have 2 more. This and another. Square root. Can anyone give us the simplest possible square root function? Very good. Now let's stop for a moment and let's go back here. You could say, well, you don't stand by your rules. You're asking us to graph these functions, but you forgot to do something very important that you always tell us. Every time I'm asked to graph a function, the first thing I have to find is the domain. Well, these are polynomial functions. What is the domain of f of x equals x? What is the domain of f of x equals x squared? What is it? All real numbers. What is the domain of this function? Okay. What is the domain of this function? Everything. What is the domain of this function? Everything. Now I have to talk about this one. So, how do I determine the domain of a square root? Correct. So, the square root requires that this quantity, it doesn't have to be x. It can be x plus 5, it can be 3x minus 10, it can be x squared plus 1500, it doesn't matter. This quantity, whatever it is, under the square root, must be greater than or equal to 0. Therefore, what is the quantity under the square root now? Can anyone read? What is the quantity under the square root? X. So therefore, x must be greater than or equal to 0. What is the domain of this function? And then we will graph it. Perfect, with a bracket. 0, infinity. Is this okay? Yes? Perfect. Now let's graph it. And we have to commit to memory this graph. Well, after today, you should remember it because we're going to graph it several times. So here's the graph of the square root of x on the domain 0 to infinity. Here it is. It's not a straight line. Odd, even, or none of the above? Very good. Not symmetric. It's not symmetric. It's not odd. It's not even. Final function, number 7, cube root. Can anyone give us the simplest possible cube root function? We have to talk about domain. Let's think for a moment. In the previous function, I was not allowed to plug in -5. It doesn't exist. The square root of -5 is not a real number. But now let's look at this function and see what we can plug in. If I plug in 8, how much is the cube root of 8? Which number I cube to get 8? 2, correct? What about 0? Which number I cube to get 0? What about -8? Which number I cube to get -8? Correct. So what does that say to you? That whenever the index is very good, any odd index, what will be the domain of the cube root, 5th root, 7th root, 11th root? Yes. This is a friendly function. This one is not. All real numbers for the range as well. So let's graph it. And this is the cube root of x. Very similar on this side. It takes its time and turns on the other. And this is the cube root of x. Odd, even, or none of the above? Odd. Okay, so we reviewed 7 different functions. We know their graphs. Now we can start talking about transformations. And why? I'll explain. Transformations. There will be 6. 1, 2, 3, 4, 5, 6 under 3 categories. The first one, shifts. They can be vertical and horizontal. The second one, reflections. WRT with respect to the y-axis, or WRT with respect to the x-axis. Last one, last category, has 2 names. Stretching / shrinking. Of course, vertical and horizontal. A total of 6 possibilities. 1, 2, 3, 4, 5, and 6. I will leave number 6 for test 2. We are going to talk about the first 5. Okay. Again, we still don't know what it is when we talk about transformations, what they mean, and we don't know why. We need to look at this. I still owe you those 2. Okay, here's what they mean first of all. Let's start with number 1. I will create 2 functions. So let's say f of x equals the absolute value of x minus 3. I just wrote that. Can I switch these two? I'm sorry. So I'm going to say 1 here and 2 here. Sorry about that. Only because I started. Or I can change it. It's up to you. And let's say g of x equals the absolute value of x plus 4. So I created 2 functions. And I'm asking you which base or basic function I used to create f and g. Did I use the cube root? Did I use the square root? Did I use the absolute value, linear, quadratic, cubic, 4th degree? Which one? Absolute value. So then the base function is the absolute value of x. I am going to graph the absolute value of x right away. Here's the graph of the absolute value of x. No, I don't want the yellow. I want the green. So this is the absolute value of x. Let's not look at g. I don't need g for now. I only need f. I'm asking myself the first question, which is this. This was the base function, which is the absolute value of x. Now this is the absolute value of x minus 3. What happened here? What did I do? I created a change in x. In other words, I replaced x by x minus 3. So let's see what that does to the function. Okay, we know how to solve absolute value equations, correct? So let's say I want to know where this point is going. We can solve that, or we can just analyze. So when x is 0, how much is y? Right, which is this point. Now, what if I want to determine what happens to this and I set it equal to 0? Where will this go? Which minus 3 is 0? That's the reason why this graph is a horizontal shift of 3 units to the right. Make sure that these 2 lines are parallel. And make sure that these 2 lines are parallel. And this will be the absolute value of x minus 3. This is a horizontal shift of 3 units to the, I'm making myself a note. I go back to my chart and I'll say, when I change x into x minus 3, for example, it can be x minus 5, x minus 7, what happens? Exactly. So make yourself a note. Right. Now let's look at function g. What do you think will happen to the absolute value when I want to graph the absolute value of x plus 4? Now the question is, what did I change? I could change 2 things. I could change x, which means this, or I could change y, which means this. And I have to establish what am I changing, because that makes a huge difference. Am I changing x, or I'm changing the outside, which is y? I'm changing x. When I change x into x minus 3, I realize that the graph moves to the right. What do you think was going to happen when I set this equal to 0? Where does this graph move? 4 to the left. So 1, 2, 3, 4. Make sure it's parallel to the absolute value of x, and it's parallel to the absolute value of x. The blue graph is the absolute value of x plus 4. So we know that a horizontal shift means a change in x. If I subtract from x, I go to your right. If I add to x, I go to your left. And this is done. Okay, let's talk about number 2. I will create two functions again. F of x equals x squared minus 4. And do you think, can you give me the other one that I'm thinking of? Perfect. That's exactly what I was thinking. Thank you. Okay, which function did I use now out of those 7? The square root, the cube root, quadratic, cubic, fourth degree, linear. What did I use? Of course. So this time the base function is x squared. Let's graph it. I remember how to graph x squared. Sorry. Here it is. It turns quickly. It's not x to the 4th. So this is the x squared. And now I have to analyze and I understand what am I changing at this point. I have x squared and I have x squared. Am I changing x? No. Here I had the x and I change it to x minus 3. Obviously it's a change in x because the absolute value no longer has x. One more time. X squared does not change. It's x and x squared and x squared and x squared. X does not change. What changes then? Yes, because this is the y value. But this time this is the what minus 4? The y value minus 4. So where does this graph go? Yes, subtract. Subtract from all y values and subtract 4. So this point goes here. This is the x squared minus 4. Again, I'm looking at the other one and I say, okay, what am I changing? Am I changing x or am I changing y? Because if I'm changing x, it's a horizontal shift. If I'm changing y, it's a vertical shift. So what am I changing? Compare these two, this with this, and tell me what we change. We are changing y. Where does this go versus this? Excellent. Up 5. Here it is. And this is indeed x squared plus 5. So this is very straightforward. Yes? Any question?
I was going to ask you if you could do another example of this with a different type of equation.
You mean you're talking about 2?
Yeah, number 2.
Sure. Let's choose a function. Any function you want.
Especially with the x squared one, that would be the easiest one to do. So I know there's one of the departments.
Sure. Let's take a look. So let's say f of x equals the square root of x minus 4, and g of x is the square root of x plus 2. Which function did we use this time to create f and g? Yes, it is the square root. I have to graph the square root of x. So the square root of x is this. Now the question is, am I changing x? No, obviously this is the same thing, it's the y value. But this is just y. What is this? This is y minus 4. Where will I graph and what happens now? Vertical shift, down 1, down 4. The square root of x minus 4. What about the second function? Yes, because we are not changing x, we are changing y. So this will be the other graph. The square root of x plus 2. My pleasure. Anytime. If you need, at any point in time, if you need extra examples, I'll be more than happy to clarify. Okay, let's look at problem. So we understand these two. Horizontal is a change in x, vertical is a change in y. So we're talking about these two, and 3 and 4 go together. Ready? Okay, here's f of x equals the square root of negative x, and g of x, which is negative the square root of x. Which function did we use this time? We did use the square root of x. Perfect. I'm going to graph it right away. Let's talk about f. What are we changing? From x, we are changing it into negative x. From x to negative x. From x to negative x. This cannot be a shift, right? We're not talking about shifts anymore. We're not talking about shifts. Shifts are done. So we're talking about something else. So, from positive 2 to negative 2. Yes?
So for changing x, would it go to the x-axis, like on the other side?
From positive 2 to negative 2 with respect to the y-axis. Okay, so let's talk about this before we graph it. Can anyone give us what we have to write in order to find the domain of this function? I have to write something and solve. Awesome. So for this function, negative x must be greater than or equal to 0 because otherwise we cannot take the square root from that number. Is that clear? We've done that? Okay, good. So how do I solve this? It's not solved yet. How do I solve this inequality? What do I have to do? Multiply or divide by negative 1. The left-hand side is? The right-hand side is? Okay, now let's think. Very good. So what would be the domain again of this function? So then I know for sure what happens to this graph. Where does it go? So it's a reflection because the domain is negative infinity to 0. So it must be a reflection with respect to the y-axis. And here's the graph. This is the graph of the square root of negative x. So when we change x into negative x, one more time, what type of reflection is this? With respect to the y-axis. Awesome. Forget about f now, it's gone. Now we look at g. What am I changing? Am I changing x? No. So this is positive y. What is this? If this is y, what is this? Negative y. Positive y, negative y. Positive y value, which is 5. Negative y value, which is negative 5. So what will happen now to this graph in order to get this one? Reflection with respect to the x-axis. Awesome. And this is it. So what do I write in my chart? I just don't have enough room in here. So with respect to the y-axis, when I change x into negative x, x goes into negative x. With respect to the x-axis, when y is changed into negative y. Last transformation. Before we look at the last transformation, I want to create a combo. Yes, any questions, please? Anything? It changes y into negative y. We're gonna look back and analyze them again if you want. Okay. So let's say we have f of x equals negative x plus 2 squared and plus 4. This is a lot more complicated function. Now the question is how many transformations we see here. Don't say anything just yet, because we have to write a note first. Note. Transformations must be presented in the order of operations. Transformations must be presented in the order of operations. What does that mean? Here's what it means. Yes, you want to say something? Go ahead.
Oh, we do each one, like it's solving it.
Like I'm evaluating it. Correct. Very good. So if I want to evaluate this for 2, which operation will I perform first? No, I can never do the exponent first. So when I have x equals 2, what operation do I perform first? Or x plus 2. That's the first step. I cannot take square before I put in x plus 2. So that would be the first operation. The function is x squared, no problem there. What would be the next step? In order of operations. Multiply by negative 1. Awesome. When I'm done, what will be the next step? Exactly. So this is the correct order of presenting the transformations. You can say, but if I reverse some of them, I still get the same thing. Correct. Full credit will be given only if transformations are presented in the order of operations. Please make a note of that. Okay. Now I'm ready, and I will have to ask you which function did we use to create this one. Yes, that is the base function. I will graph the base function, which is x squared. So here it is. It turns quickly. So this is x squared. Now I would like to list the transformations. You already told me that number 1, the first transformation, will be on x squared. Which one? One more time. First transformation is x plus 2. What does this do to the original function or base function? Left 2. Very good. Number 2 is a transformation on number 1, not on this anymore. So what will be the next step once I have this? What will be the next step? The transformation on this. Very good. What does this do? And always ask yourselves, am I changing x or y? Am I changing x from number 1 to number 2? Am I changing x from number 1 to number 2? No. What am I changing then? So what do I do? What does this mean? If this is y, this is negative y. What does that do? Reflect. No, it's not down. Exactly. A reflection. WRT with respect to the x-axis. It's a multiplication. That's why it's not up or down. And finally, number 3 is a transformation on number 2. So in order to get the whole thing, I would write negative x plus 2 squared plus 4. Again, I'm asking myself, am I changing x? No, I'm not changing x. I'm changing where does this graph go versus this one? It's plus 4. So this is y, and this is y plus 4. Where does it go? Very good. Indeed. I'm going to graph the other two. When we talk about transformations, I looked at your book. I don't need this. Okay, I just want to show you. When we talk about transformations, okay, when we talk, I didn't need to do that. I don't know why I did it. So when we talk about transformations, I don't care for ordered pairs. I just want the shape of the graph. I don't care to present anything accurately unless, or 100%, unless I'm asked find the x and y intercepts, find the vertex, find this, find that. But if I'm asked graph using transformations, this is a waste of time. There is no need for this. Maybe they were just explaining where it's going, which is fine. Okay, so this is an accurate graph, but we don't need ordered pairs. So you already told me to graph left 2. I'm going to graph left 2 as the first transformation. So this is x plus 2 squared. Then you told me to reflect with respect to the x-axis. Okay, I'm going to reflect. So this is negative x plus 2 squared. And finally, you said to me what? Up 4 of this function, of the green function. Up 4 means 1, 2, 3, 4. And here's a rough graph. I don't care for points here. So this is the final graph. And it is y equals, or f of x equals negative x plus 2 squared plus 4. And this is a combination of 3 different transformations. Left 2, reflect, up 4, please. We already had to reflect it. Number 2, it says reflection with respect to the x-axis. So from shifting it to the left 2, I had to reflect it, and then the reflected one goes up because that's the correct order of operations. My pleasure. Anything else? Okay. If you want, we can choose one more and then put in the last one, or we can do the last one, number 5, and then put in all of them. All of them? Yes? Okay. So number 5. Let's look at f of x equals twice the absolute value of x, and g of x equals 1/3 the absolute value of x. Which function was used to create f and g? Awesome. Thank you. So here's the absolute value. And like before, I'm going to ask myself, what am I changing? I am changing y. No, I'm not changing x. X is the same thing in the absolute value. Nothing changes. X is not touched by anything. So since it's outside, this means that this is y, and this means that this is, if this is y, how much is this? 2y. Okay. We know the graph of the absolute value. If I multiply all y values by 2, question, will the graph do this? Or from the absolute value, the graph will do this? Yes. However, it's called vertical stretching of the graph. So let's graph the absolute value of x first. Here it is. Bisecting the first and the third and the second. Now we graph these functions so many times that I'm sure you're already, can graph those anytime. This height, which is y, gets multiplied by 2. So this point goes here. this height gets multiplied by 2, so this point goes here. So that's why the new graph is this. This is twice the absolute value of x. This is called a vertical stretching of the graph by a factor of 2. Awesome.
So if it's greater than 1, it's vertical stretching, must be less than 1. Or
Vertical shrinking. Vertical shrinking.
that's a polynomial.
It's pretty much the same thing. You will see when we get to number 6. Okay. So now I'm comparing these two. Am I changing x or I'm changing y? Correct, because there is nothing that changes or touches x. It's outside. So if this is y, how much will this be? 1/3 times? Okay, what does that mean? That all heights will not be multiplied, but will be by? Okay. So at any point in time, for this y value, I will divide it by 3, and this will become a new point. For this, I'm dividing it into 3 equal parts, and this will become the point. So therefore, on this side, I have this. And on this side, I have this. Oops, missed it. So this is the graph of 1/3 x. We're going back to our summary so we can fit it in. What are we going to write? Oh, I forgot to put in writing what this means. So 1/3 the absolute value of x is a vertical shrinking. We shrink the graph vertically. Vertical shrinking by a factor of, which one?
1/3.
Thank you very much. So, and this is the end of the material for test 1. So let's write it here. We did not discuss number 6 at all. So vertical stretching or shrinking is when I change y into twice y, or a number greater than 1, or when I change y into 1/3 y, 1/4 y. So y into twice y is an example, and y into 1/3 y. What does 2y mean? Vertical stretching by a factor of. And what does 1/2 or 1/3 mean? Horizontal shrinking of the graph by that factor. And this, we'll discuss it after the test, a week from Thursday. Okay, so now let's put all these in a combo. Okay, here it is. Let's say f of x equals -2 the square root of x plus 4 plus 3. Okay, I have to ask myself, what is